this is a big problem. It's a really big problem. I see it a lot in my patients with PCOS or patients with uterine fibroid. These chemicals are influencing the behavior of estrogen sensitive tissue, and uterine fibroids have tons of estrogen receptors. So you want to make sure that as part of the treatment and getting that person better is to reduce their exposure to these environmental estrogens. And this is really the why. So I'm going to talk about the environmental impact on our, on chronic disease. So linking environmental exposure to toxins and chronic. So this is what we're covering today and in subsequent meetings. So the World Health Organization made a comment stating escalating rates of neurocognitive, metabolic, autoimmune, and cardiovascular diseases cannot be ascribed only to genetics, lifestyle, and nutrition. Early life and ongoing exposures and bioaccumulated toxicants may also cause chronic disease. And what I do when I see patients, I oftentimes review their environmental exposures because we're living in a toxic soup of chemicals. We're exposed to so much everywhere, from what we eat, what we put on our bodies, what we're breathing. It's just everywhere. Chemicals are ubiquitous in the environment. And there's more and more studies coming out showing the impact that these toxicants have on our physiology. So it's really important for clinicians to consider the environmental aspects of health. So these are just examples of some toxicants, and there's a difference between toxin and toxin. Often people use the word toxins loosely, but that's referencing an endogenous production of a toxin in something made in the body internally. Toxicants are more man-made. So we're talking about pesticides, insecticides. We all know tobacco it's not healthy. So these are some examples of toxicants that we're exposed to, heavy metals. I often work with patients who either are in construction or firefighters or painters. And oftentimes I see a lot of lead and cadmium in these patients. And so this is something that accumulates based on occupational exposures and just being in a world of soup of chemicals. It's just what you're going to find. And so heavy metals, pesticides, disinfectants, mold is a big one. It's a biotoxin. I work with patients with mold, and 70% of US homes have mold and no one knows it. And so you have to be considering mold as part of your differential if a person has respiratory symptoms or they have these chronic infections. They can't really figure out what's going on, and all of their labs are normal and the doctors can't figure it out. You go in, get pulmonary testing, and they say, well, we can't figure out, it's not asthma, we don't know what it is. Oftentimes it's mold. So there are other toxicants, from occupational exposures, plastics, rubbers, perfumes, to personal personal care products that we're using on our skin. So women leave the home with over 500 different chemicals every day, from the hairsprays and et cetera, dyes. And so there's a lot that we're being exposed to, and it does impact our health. So when we're exposed to these chemicals, they have the ability to impact multiple organ systems. Obesity, influencing metabolism, lipid and glucose metabolism, creating weight gain, diabetes, just the endocrine system, pulmonary system, the central nervous system, it goes on, the gut. These chemicals can impact, they directly interact with different systems of the body and can cause pathology. This is interesting. This was an issue from Nature earlier this year. Tumor promotion, air pollution drives lung cancer, and non-smokers. How many of you know someone who's had lung cancer but no history of smoking? I personally know people who've developed lung cancer and had no history of smoking. And oftentimes people think, oh, just because you smoke, you're going to get lung cancer. Or if you have lung cancer, you must have been a smoker. That's not true. That's not true at all. In fact, they say here, air pollution is associated with the development of lung cancer. Analysis of clinical samples and mouse cancer models suggest that inflammation and a tumor promotion process induced by polluted air are the major culprits. The World Health Organization has concluded that this dangerous trajectory has resulted in an increased risk of lung cancer, with an estimated 250,000 worldwide deaths per year attributable to atmospheric pollution. Okay, so this is a real issue. Like I said, I work with patients with lung cancer, and it's sad because oftentimes these patients are young, in their early 30s, and they have advanced disease, metastatic disease, unfortunately. So here are two proposed hypotheses, excuse me, as to the development of regenesis of the lung. So in the first model, we have a lung cell, and there's a mutation that happens as a result of exposure to an environmental toxicant in the air. And then it promotes changes at a cellular level, and then it promotes the development of a benign tumor. And when the conditions are right, that benign tumor will develop invasive properties, and that will lead into a fully malignant cancer. By the time a person gets their lung cancer diagnosis, it's already late stage and have already metastasized. I think about 10% of it has already metastasized to the brain. So it's one of those cancers you have to catch early. And if there's a family history of any cancer, you really want to be ahead of the cancer, the cancer diagnosis, if you can, with utilizing early cancer detection technology. And the next model here, and letter B, there's some underlying mutations that what they propose. There's underlying mutations in these cells of the lungs. And when the conditions are right, when there's some kind of environmental insult from like a polluted toxicant from the air come in contact with an existing tumor or cell that already has mutations, it will mount an inflammatory response. The macrophages or white blood cells release these cytokines that create all kinds of inflammation, and that will promote the formation of a tumor. And then the lid keeps going on, and it develops into, a tumor that has invasive properties. And there you have it, a lung cancer. So these are two, in my opinion, good models for at least hypotheses in explaining the underlying mechanism as to how air pollution is driving lung cancer. But what they both have in common is that air pollution is a driving factor. So when I work with anyone with chronic disease or lung or any kind of cancer, any kind of solid tumor cancer, there's always a driving mechanism, and environment is one of them. And we have to look at this, because when people have chronic disease and when they have cancer, it's usually multifactorial. And because it's multifactorial, it means there needs to be a multifactorial approach to investigation and really looking at the underlying drivers to the pathology. And environmental medicine is one of them. So this is interesting. This is a review looking at how endocrine disrupting effects of BPA. So we've all heard of BPA, but there's many different types of bisphenols. And this is looking at the impact of BPA on cardiovascular health. And what they found is that their findings suggest that BPA impairs, they were looking at the mechanism. How is BPA exposure increasing the risk for cardiovascular disease and risk factors? Our findings suggest that BPA impairs cardiac excitability through intracellular mechanisms involving the inhibition of main ion channels changes in calcium. So calcium is a very important ion for the cardiac tissue. And so BPA can impair that process, and induction of oxidative stress and epigenetic modification. So we have an epigenome, which is our environment, our lifestyle factors, our dietary factors, behavioral practices can influence the epigenome. These are genes that are influenced by lifestyle and dietary practices, and BPA can facilitate that change. Our data support that BPA exposure increases the risk of developing cardiovascular diseases, including atherosclerosis, and its risk factors such as hypertension and diabetes. Furthermore, BPA exposure is also particularly harmful in pregnancy, promoting the development of hypertensive disorders during pregnancy. In summary, BPA exposure comprises human health, or compromises human health, promoting the development and progression of cardiovascular disease and risk factors. So don't have any, try to reduce your exposure to BPA, and you can sweat BPA out. That's what this is all about. When we say detox, you can actually sweat it out and also reduce your exposure. And we'll talk about how to do that in subsequent presentations. This was a statement from the American Heart Association. They understand that obesity is multifactorial and complex, and therefore must be addressed on multiple levels. And endocrine disrupting chemicals, such as diethylstilbestrol, which is synthetic estrogen, bisphenol A, phthalates, organotins, have been proposed as potential obesogens. Now, obesogens are chemicals that can promote obesity. Okay, they contribute to a toxic chemical burden that may initiate or exacerbate the development of obesity and its related comorbidities. Okay, and these chemicals, endocrine disrupting chemicals, are found in plastics, cosmetics, shampoos, soaps, lubricants. And I don't want to overwhelm you all because it can be overwhelming. It's like, oh my goodness, there's just chemicals everywhere. I can't get rid of them, but there's some things that you can do to reduce your exposure. So the Endocrine Society says when endocrine disrupting chemicals block connections between hormones and their receptors, they reprogram the parts of the endocrine system that govern metabolism, energy balance, and appetite. Endocrine disrupting chemicals change the sensitivity to glucose and metabolism of lipids. All of this predisposes a person to gain weight. Okay, so they've done studies in animals, and what was interesting is that as we're seeing obesity just continues to climb in humans, they're actually seeing the same phenomena in animals. Animals are gaining weight too, and it's because of the chemicals. As I mentioned, BPA is just one type of bisphenol. We have BPB, bisphenol C, bisphenol S. So just an FYI, if you see anything that says, and we'll talk about this later, and we'll give you all an opportunity to talk about this, but when you see things that say BPA free, that's not excluding the other BPAs, the other bisphenols. So there's other types of bisphenols as we're seeing here. And this is just showing, this is a schematic just showing, you know, what role does it have at a cellular level? So when we think of disease, it really starts at a very fundamental level in our cells. There's a lot going on. So BPA has the ability to bind to receptors. And these receptors, once they're activated, they can send signals within the cell and alter intracellular proteins that, as we see here, the IRS1 and the AKT. They're downregulated or upregulated in ways that will influence metabolism. It can downregulate BPA binding to receptors, can actually downregulate mitochondrial function. Mitochondrial dysfunction can lead to many types of, sorry, I got to pop up here. Mitochondrial dysfunction can affect so many different things. That's a whole different subject, but BPA has the ability to directly influence mitochondrial function and affect how energy production of the cell is carried out. And then because of the intracellular proteins that are being downregulated because of BPA exposure, it does influence glucose uptake. It downregulates glucose uptake in the cell. And this is what's happening at a cellular level. This is what happens when we're exposed to BPA, or if we're exposed to other environmental toxicants. This is the direct mechanism. It's directly influencing how the cell behaves, binding to receptors, and influencing the intracellular physiology. And this is what's creating weight gain and promoting diabetes. So this is different aspects of how BPA can influence different parts of complications of diabetes, diabetic cognitive dysfunction. BPA can influence that by downregulating the insulin receptivity inside the brain, promoting nerve damage, affects the kidneys as well, and affecting the filtering units of the kidneys and creating scarring. It also affects the pancreas and downregulates the production of insulin, and it affects the lipid metabolism, affecting cardiovascular health. The list goes on. This is just one example. I'm just mentioning one example. There's just so many different toxicants. And if I were to talk about everything, you guys will be here all day. This is just an example of BPA and how its role in influencing different parts of the disease process of a person with diabetes. When we're exposed to toxicants at the receptor level, it affects how the intracellular mechanisms are performing inside a cell, and that ultimately changes the behavior of the cell. Now, once in a cell, the BPA or any kind of chemical have the ability to affect our genomics, our DNA. So it promotes genomics instability. These chemicals, either radiation or combustion products from auto exhaust, or even dietary the things that we're consuming, it has the ability to create breaks in the DNA or create add-ons to our DNA that aren't supposed to be there. And what happens is it causes the DNA material or genetic material that is responsible for everything that goes on in our body. When it's mutations at that level, when there's damage to our DNA, that promotes disease. If the conditions are right and there's a lot of other things going on, it just might actually express proteins that can actually be responsible for creating disease. So we want to protect our DNA, and unfortunately, the environmental toxicants that we're exposed to damage our DNA. And one example, dietarily, what I've talked about before, heterocyclic amines, when you're frying red meat, they release these carcinogens. They're very mutagenic, and they have the ability to change and alter our DNA and promote genomic instability. We don't want that. So I have a question for you. Do you currently take active steps to reduce your toxic exposure? A, no, because I was not aware of the dangers of environmental toxins. B, yes, I make efforts daily to avoid environmental toxicants. That's what it is. Or C, sometimes. Well, for those who are learning this for the first time and learning the role that environment plays in health, stay tuned, because there's a lot more that we're going to cover. So the Environmental Protection Agency defines what an endocrine disrupting chemical is. So I mentioned BPA, but there's so many other types of endocrine disrupting chemicals like phthalates. And they're defined as an exogenous agent that interferes with the synthesis, secretion, transport, binding, action, or elimination of natural hormones. So let me explain this. When your body, so I'll just use the ovaries. I mean, we have different endocrine systems, but your ovaries pump out estrogen, progesterone, your adrenals pump out cortisol. Whenever a tissue produces a hormone, that hormone needs to be secreted and transported by binding proteins to the local tissues, the target tissue that require those hormones. And the hormones bind to receptors. And then once they bind to receptor, they facilitate these intracellular mechanisms to drive the action of that. But they have a half-life. The hormones have a half-life, and they have to be eliminated. And what they're saying is, if there's any synthetic hormone or something that's not made by the body comes in and it interferes with that entire process, then that's an endocrine disrupting chemical, because it's interfering with how your endocrine system functions. And so if it affects the elimination of natural hormones in the body, which are responsible, these hormones are responsible for the maintenance or homeostasis, balance, okay, reproduction, and the regulation of developmental processes. These hormones, synthetic hormones, have the ability to impact virtually all aspects of hormone physiology. And this is a bad thing. This is just a summary of the 10 different ways and some of the chemicals that can actually facilitate disrupting the endocrine system, either from hormone distribution or breakdown, or even hormone transport like BPA, fungicides, BCBs, hormone synthesis, atrazine. Oh, that's interesting. We're going to talk about that one. Perchlorates, phthalates, and perfumes, ladies. You like perfumes? Or, plastics. They have the ability to impact hormone synthesis. And so I'm not going to go through this whole list here, but these are the various different types of endocrine disrupting chemicals that can affect how a hormone behaves in your body. And so the easiest way to say, I can say this because some of us are Christian, but it's a counterfeit hormone. Like it mimics what your body naturally produces, and it's a counterfeit. We know the devil's into counterfeit. This is what happens in our body when we're exposed to these environmental toxicants. And here's an example. I'm just going to hone in on this. If you look here at BPA, look at the left and you see signaling systems affected by BPA. So thyroid signaling. Look at this. The BPA is able to bind to thyroid receptors and then bind to receptors that promote fat accumulation, lipid accumulation, and promoting obesity, estrogen signaling. Yes, BPA can impact estrogen signaling. So all of my breast cancer patients, what do? I have to reduce their exposure to exogenous sources of estrogen, okay? And BPA is one of them, okay? Androgen signaling, glucocorticoid signaling, because BPA has the ability to lock in on these receptors and influence these different cell types. If you look on the right, you see 17-beta estradiol. This is the biological form of estradiol. And we see bisphenol A. If you look here at the blue highlighted region, this is a hydroxyphenyl group. If you see the backbone structure of estradiol that's made in a woman's body is actually similar to the backbone structure of BPA. So what do you think is going to happen here? BPA is able to bind to estrogen receptors. Imagine a lock and a key, and you put in the key, and the key, how many of you, I know you notice you put in the key, the wrong key, but it fits into the lock, but it's not the right key, so it doesn't open. So it's kind of like that with these chemicals. They can bind, but they actually do have the ability to, and yes, who's talking? They actually have the ability to influence the behavior of that cell and exert their effects in a way that is unfavorable. Of course, if it's an estrogen receptor, we don't want to have constant signaling of the estrogen receptor to promote proliferation, unwanted proliferation of breast tissue or uterine tissue in women who have uterine fibroids, for example. This is a big problem. It's a really big problem. I see it a lot in my patients with PCOS or patients with uterine fibroids. These chemicals are influencing the behavior of estrogen sensitive tissue, and uterine fibroids have tons of estrogen receptors. So you want to make sure that as part of the treatment and getting that person better is to reduce their exposure to these environmental estrogens. So here's another one. This is structure of thyroid hormone. Same thing applies to my thyroid patients. I have to reduce their exposure to exogenous sources of hormones because the thyroid is a gland that produces hormone. And so if you see here in letter A, T3 hormone, okay? Thyroid produces 80% T4 and it converts into T3, and that's the biological form that the tissues use and is also converted in other tissues. If you look here at B and C and D, these are different bisphenols. So you have BPA, you have BPS and BPF. You see the structure there? They both had those hydroxyl groups, and it matches the hydroxyl group on the structure of T3. And so this is why if you have a thyroid problem, you want to reduce your exposure to these environmental endocrine disrupting chemicals, because they will and definitely will block the receptors and try to mimic what the thyroid would do. And that's, you don't want that. And that can either lead to an upregulation or downregulation, hypo or hyperthyroid condition. So this is a problem, and it's something that definitely should be considered. So atrazine, we talked about, not just a couple of slides. This blew me away. So listen, look at this. Atrazine, so this is a study from Cal Berkeley, and they were looking at the role of atrazine, which is a pesticide, and they spray it on corn, they spray it on crops. It's a very common pesticide that's used. And what they found when they sprayed frogs, male frogs, listen to this, atrazine exposed males were demasculinized, chemically castrated, and completely feminized as adults. Wow. 10% of the exposed genetic males developed into functional females. What do you think is going on there? What's going on? This is sprayed on the stuff we eat. Okay. Males that are genetically male frogs are turning into females. Have mercy. These toxicants affect the mitochondria. These are the different parts of the mitochondria. And we have to appreciate the mitochondria is the biotransformation, our bioenergetics, and how the body produces energy. If you feel like you just don't have your energy anymore, you're always tired, this is where it's at, the mitochondria. We have to improve mitochondrial function and improve adrenal health, the hypothalamic pituitary adrenal axis, cortisol regulation. All of these things, it was what you have to look at, and is influenced and impacted by environmental toxicants. And the toxicants can affect the electron transport chain. This is different parts of the mitochondria that's responsible for energy production. And so basically, long story short, when you're exposed to toxicants, it's damaging to the mitochondria. And that's what's also responsible for giving people energy and taking the energy away. And I won't spend a whole lot of time on this. This is the impact that toxicants have on our gut. The gut microbiome is impacted. They also play a role in biotransformation of toxicants when we're exposed to something. The microbiome facilitates the metabolism. I think it's 75 or 80% microbiome plays a role in breaking down our toxicants that we're exposed to. So it also creates dysbiosis. It shifts the microbiome in a way that's not healthy and promotes intestinal hyperpermeability. And that's never a good thing, because that's been connected a lot to many different types of the 100 types of autoimmune disease. So we have to keep in mind, it does impact the health of the gut, the environmental toxicants that we're exposed to. The Scientific World Journal says intervention to reduce the body burden of persistent toxicants, the field of clinical detoxification, constitutes a fundamental and urgently required approach to reduce intoxicants related health issues. This is what I practice, one part of what I practice. I don't detox all of my patients, but I do utilize it when I do the testing and I see people are really toxic. And even if you don't do testing, if you've not done a detox in a long time, you've not given your body an opportunity to purge and clean stuff out, this is a great opportunity. So I have one more question. Does your doctor consider environmental toxin exposure as part of your medical history? A, no, I'm never asked about my environmental exposures. B, yes, My doctor takes into account my environmental toxin exposures. Well, as we can see, we really should be thinking about that. Even as patients, we should consider, no one really thinks about the toxins in their home and air filters. And, the indoor air is actually more toxic than outdoor air. And we really need to think about these things and what we're exposing ourselves to. Okay, genetics loads a gun, but environment pulls a trigger. So you have control over your exposures to some degree from a dietary perspective, from environmental perspective, something just short. If you're at a grocery store, don't take the receipt. It's loaded with BPA. Okay. Don't eat from cans, things of that nature. And they've actually done studies looking at just making those small adjustments makes a big impact, significant impact on how much BPA is actually in your system. Okay. So just those small changes can have dramatic effects on your health.